All right. Hello, everybody, and welcome to our final videos of topic 4. This is breaking down the second half, the nitty-gritty parts of this topic, and I think it'll go relatively quickly and lightly, especially in video format. We're going to begin with the two-column proof format of deductive reasoning and how to present our arguments. Now, we're not going to jump straight into the two-column proof. We're going to do an example deductive reasoning problem. That way we can better understand how to convert one of these arguments into two-column proof format and why it's helpful. So let's check out one of these arguments, one that will prove very handy if you want to go for that bonus question on the assessment. Suppose you are visiting an island, and on this island there are only two kinds of islanders, knights who always tell the truth and knaves who always lie. Why is it impossible for an islander to say, I am a knave? So let's break this down. I think it's impossible for knights to say this, right? A knight cannot say, I am a knave, right? I am a knave. They can't say that. Why not? Because that would be a lie, right? And a lie would be a contradiction. It would contradict the fact that they cannot lie, right? Okay, so why can't a knave say it? I'm a knave, right? Well, they can't say that because that would be the truth. And once again, that is a contradiction, right? So neither knights nor knaves can say this. And if both of them can't say it, then nobody can say it because there's nobody left on the island besides knights and knaves, right? So therefore, it's impossible for an islander to say this. Now, this argument, did I present it great? If you were just to look at this slide, would you be able to figure out what I'm saying here? Maybe, especially, if you can read my handwriting, right? But, it's not the greatest format. It's not really easy to follow, and you might not necessarily understand why a contradiction is a problem, what this truth has to do with the must lie part, right? And what this thing is doing here, and why it's impossible for any islander to say it, right? Didn't make that step very clear at all. We want to make our arguments very clearly presented. A lot of us in math so far have struggled with being able to clearly present our deductive reasoning and even doing it ourselves, right? Obviously, I already knew the answer to this argument and everything, but if you're trying to figure it out yourself, it might not be the best way to just kind of explore it with a bunch of doodles, right? You want to have a structured way of presenting it that's clear for you and for other people to follow. That is the utility of a two-column proof. You'll notice when I was presenting my reasoning, I often did something in a two-step format. I told you something I thought was true or knew to be true, right? And then how I knew it must be true. For example, I said knights cannot say this, right? Because if a knight said it, it'd be a lie, and knights must not lie. Knaves cannot say this because if a knave said it, it'd be the truth, and knaves cannot tell the truth. See how it always breaks down to something I'm saying that must be true, and then why it must be true. I present some evidence and I back it up. And by creating enough of these in a row, I lead towards the proof, the thing I'm trying to prove, which is in this case, it's impossible for anyone to say this. So that is the core of the two-column format, right? Two kinds of things we say, one presented as a truth, the other one building off that to back it up, right? That is the two-column proof format. On the left, we put statements, the steps that help to support and lead to our conclusion. So that was, if I want to prove it's impossible for anyone to say it, I need to prove it's impossible for each person to say it. And luckily, I can break down everyone into one of two categories, knights or knaves, right? That means I have a very simple path towards completion, right? Prove it for knights, prove it for knaves. So that's what the statements are going to consist of. But to prove it, I need to back up my arguments. If I just said, trust me, knights can't say that, you probably would trust me, right? But you don't have to, and there's no reason for you to. That's what the reason is for. For everything I say that must be true, I supply the reason for that thing to be true. And I always begin with what I'm given, right? The initial starting point of the problem, the building blocks, like what we've seen in geometry before. And we always end with what we're trying to prove. Every statement should have a reason. You can't just throw out a statement willy-nilly and then hope that I trust it because everything else has been true so far. You got to have a reason for every statement. That's the key to deductive reasoning. Because in deductive reasoning, remember, our goal is to convince and persuade people. They should be able to read through this and follow every single one of your statements and go, that must be true. Because the proof is the only thing that could be true given everything else you said. That's the power of deductive reasoning, that everyone who reads this and agrees with the initial starting point will agree with where you end up. So let's look at an example, right? What I was saying earlier, let's see how it translates into a two-column proof. I'm not going to show the whole thing, just the part of me proving that knights cannot claim to be knaves. There are two different kinds of islanders, knights and knaves, no others. Knights cannot lie. These things are given. They're the things we're starting with, right? Two things that were given. By using those together, I can prove that a knight claiming to be a knave is lying because, well, knights are not knaves, right? And a knight cannot claim to be a knave. Why? Because knights cannot lie, which was one of my given pieces of information. So as you can see, each of my statements has a reason backing it up. By putting together these reasons, I prove that every statement I say must be true. If I was to repeat this process with knaves, right, I would then be able to put together those two proofs, click them together. Now I've proven it for both, and then I can just finish it off by saying, if knights can't say it and knaves can't say it, there's nobody who can say it. And if nobody can say a statement, it is a statement that is impossible to make. There you go. So again, why do we do two-column proofs? What's the point of learning all this stuff, right? Because every one of us has a unique and an interesting way of thinking, right? And presenting our thinking. But in math, we want to try to figure out the proof and the truth behind your unique ways of thinking because we can all understand each other and learn from each other. And the best way to do that is to find agreed upon universal formats to do it, right? So we can all very clearly understand what everyone else is thinking. Two-column proofs are kind of the assumed way we present deductive arguments in a math class, right? So that's why it's really important to get familiar with the structure, that every statement has a reason, that they're obviously connected, either by being on the same row or by sharing the same number, like number one, number two, number three, and so on, right? And that we back up every statement with a reason leading from a given to our ultimate goal, the thing we're trying to prove. Okay? All right, so in the next video, look forward to me breaking down some of the things I kind of obliquely referred to this time, the parts of a proof, the things we start with and the things we're ultimately trying to prove. From there, we'll start exploring some of those things we start with and then exploring some of those things we're trying to prove. All right, I look forward to seeing you then.